My name is Flash Isaac, and I am a teacher from the future.
When I was much younger, I saw thousands of people fail Jamb and unable to gain admission.
After defeating Jamb, I came back in time to help you score high in Jamb. I am doing this with the help of the Flashlearners Jamb app and a series on YouTube according to Jamb syllabus tagged 120 days to Jamb with Flash Isaac. In this series, we shall be defeating Jamb and as well get justice for everyone who Jamb has served breakfast. This is episode number 17 of the 120 days to Jamb economics with Flash Isaac. In this episode, we shall be looking at the measures of dispersion. Before now, we've been able to look at the methods of economic analysis, which are deductive reasoning, inductive reasoning, positive reasoning, and normative reasoning. We're also able to look at other tools used in economic analysis: table, graph, charts. We looked at the measures of central tendency, which are the mean, the median, and the mode. They are also referred to as the measure of location. In this class, we are dealing with the measures of dispersion. The measures of dispersion deals with how values or data spread about the mean. How do data spread about the mean? It is also referred to as the measure of spread or the measure of variability. Anytime you see range, mean deviation, variance, and standard deviation, we are talking about the measures of dispersion. So, range is a measure of dispersion, it is a measure of spread, it is a measure of variability. Mean deviation is a measure of dispersion, measure of spread, measure of variability. Variance and standard deviation are measures of spread, measures of dispersion. They are also measures of variability. Now let's look at the characteristics of range. Range is easy to calculate. In fact, if you are given values 2, 7, 8, 1, and 6, range is simply the difference between the biggest number and the smallest number, which is h minus l, highest minus lowest, or biggest minus smallest. That is range. In any case, in most questions, in fact, in any question, this is the way questions come under range. You'll be given so many values and asked to look for the range. Simply subtract the biggest from the smallest. Here, 8 is the biggest and 1 is the smallest. So 8 minus 1 is 7. That is the answer. It doesn't get harder than that. If you are given 500 numbers, look for the one that is the biggest, look for the one that is the smallest, and subtract. You've gotten your range. So you see, it is easy to calculate, it is easy to understand, because in less than a minute, I've taught you range, and I'm sure you understand so well. It is poor because it only considers extreme values. Although range is easy to calculate, easy to understand, but it is a poor measure of dispersion in the sense that if you are given 1000 numbers, 1, 2, 6, 7, 19, 100, 1000, the biggest is 1000, the smallest is 1, meaning 1000 minus 1 is your range. It considers only the extreme values. What happens to the other values that are not used? So, it is not a good measure. It uses only the extreme values, or the values in the data are not used. And it is used for quality control, for accepting or rejecting products. The idea of range is knowing the difference between products, difference between value. If the difference, you have 10 products and the difference between the best and the other one, or products that are expected to be the same, you have marker, different markers. You check their quality, you discover that the difference between the one and another is wide. That is wrong because they are supposed to have very close difference. In fact, small difference. So if the difference is big, it means that there is variability in the product. So you don't need to accept that. So range can be used to calculate open-ended distribution. Open-ended distribution are distributions without boundary. So we use range to calculate that. How about mean deviation? After range, we have mean deviation. Mean deviation. The mean we dealt with in episode 15 is also referred to as arithmetic mean or the mean. Here, in mean deviation, it involves all the data and it is better than range. Range doesn't involve all the values, but mean deviation involves all the data. So it is better than range. And it is difficult to investigate behavior since deviations are taken as positive. Look at it. This is the formula for mean deviation. This is for an ungrouped data and this is for a grouped data. Now look at something. This S minus S bar is also referred to as D. You notice it is in between these two guys. This is referred to as absolute value. Absolute value. What absolute value means is that if S is 2 and S bar is 4, S bar is mean. So a value minus a mean is deviation. Normally 2 minus 4 should give you minus 2. But since we need an absolute value, you ignore the minus. So instead of minus 2, you simply say 2 because you just need the absolute value. Mean deviation only considers the absolute value because deviation are taken as positive. Variance considers only the absolute value. Standard deviation considers only the absolute value. So how do we know that a deviation is negative? How do we know that the number is supposed to be minus when we assume the end as positive? So that is a characteristic of all of them and a bad one. For variance, it is not a good measure of dispersion because the variance and standard deviation, they have the same characteristics. That's why I continued here. They square the actual value. For mean deviation, you see summation of f, s minus s bar all over summation of f. At least the deviation is taken as absolute, as positive, which is difficult to investigate the behavior. But for variance and standard deviation, not just taking the deviation as positive or absolute, they square the deviation. So any value they get, they square it. So it is not even the actual value we are seeing. We are seeing a square value. And deviations are taken as positive for both variance and standard deviation. However, they involve all the data given. You use all the values to solve. There is it. Measure of dispersion, range, variance, and standard deviation. We are done with range explanation and calculation for range. Now let's look at how questions come under mean deviation. Then we look at variance and standard deviation. The good news about variance and standard deviation is that for variance, the formula is summation of s minus s bar squared over n, or summation of f, s minus s bar squared over f. S is a value and s bar is the mean, meaning we need the frequency, the value itself, s in the data, and the mean to calculate variance. It will make a lot of sense to you very soon. Now, after you've gotten variance, standard deviation is the square root of variance. Meaning, if I say find standard deviation, simply look for the variance, any answer you get, square root it, you get standard deviation. So, anytime we solve questions under standard deviation, then to get the variance from that, just square the standard deviation. So, meaning once told, we keep these two base. Measures of dispersion. These are the various ways questions come under measures of dispersion. The first way is that you'll be given an ungrouped data, meaning values that are not in tabular form or in frequency distribution, and you'll be asked to find the mean deviation, to find the variance, or to find the standard deviation. You will be given numbers or values in frequency distribution or table like this and asked to look for the mean deviation, to look for the variance, or to find the standard deviation. Or you'll be given a table with interval like this, not a single value but interval and frequency, and asked to look for the mean deviation, the variance, or the standard deviation. How do you do that? For ungrouped data, something like this, to find mean deviation, it is simply this is n. Summation of s minus s bar all over n. That is mean deviation. Summation of s minus s bar all over n. Let's do it this way. S is actually the values. For an ungrouped data, each of the values are referred to as s. So let's do something like this, tabular form, to make life easy or easier for us. You say s is 4, 5, and 9. If you are given set of values, each of them is referred to as s. So this is your s. Mean deviation needs s bar. What is s bar? S bar is the mean, and s bar is equals summation of f over n, or summation of fs over summation of f. In summary, for this ungrouped data, to find the mean, we simply do the summation of s over n. We add all the values, 4 plus 5 plus 9 divided by 3. This is the mean of the values. And 4 plus 5 is 9. 9 plus 9 is 18. So 18 over 3 is equals 6. S bar is equals 6. We found the S bar. So we are given an ungrouped data and asked to find the mean deviation. First of all, draw a table like this. Let here be S. Bring out each of the values, no matter how many they are. After that, look for the mean, S bar. After looking for the mean, ask yourself, what is n? N is how many values we have. So 1, 2, 3. We have just 3 numbers. N is equals 3. After looking for n, let's find s minus s bar. Let's subtract each of the numbers from the mean. That is the absolute value. So next to the table, write s minus s bar. This is Jamb and objective, and because I'm explaining, it will take time. But if you are solving on your own, all this won't take you up to 3 seconds. You just draw a table, bring out the data, find the mean, like that. Practice makes you very, very fast. The reason people don't finish in Jamb is not because of the method they use to solve. It's because of the fact that they think in some questions and they don't know answers to certain questions. So they begin to think and reason. If you know answers to the questions, no matter how long or the long form you follow, you will certainly finish. You know, even if you solve everything one after the other, you will certainly finish in the exam hall. 4 minus 6. S is 4, S bar is 6. In this case, 5 minus 6. In this case, 9 minus 6. This is equals, this is equals, this is equals. 4 minus 6 is actually minus 2. But here we are dealing with absolute value. Ignore the minus. Any minus, ignore. We only deal with positives. So this gives you 4 minus 6 instead of minus 2, put only 2. 5 minus 6 instead of minus 1, put only 1. We don't deal with minus. 9 minus 6, 6, 7, 8, 9, 3. So this is your S minus S bar. But the formula is find the summation of S minus S bar. So the summation will simply be 2 plus 1, 3, plus 3, 6. So the summation of S minus S bar, or summation of D, is equals 6. So food is ready. Mean deviation is equals summation of S minus S bar, which is 6, divided by N, which is 3. That is equals to, mean deviation is 2. What if the question had said, find the variance? If we are looking for variance, everything remains the same. Look at it. From where we started, bringing out this table, up to finding mean and n, everything is valid. The only difference that finding variance will bring to the table is that it will give us another column. And what is this column? The column is S minus S bar squared. Meaning, after finding we know S, after finding S minus S bar, we square each of the values. So here is 2 squared, that is 4. Here will be 1 squared, that is 1. Here will be 3 squared. If I am not wrong, that will be 9. Which means instead of just summation of s minus s bar over n, we now have summation of s minus s bar squared. These are s minus s bar squared. So the sum of s minus s bar squared is equals 9 plus 1, 10 plus 4 is equals 14. And variance is therefore 14 over n, that is 3. This is equals variance. What if the question had said find standard deviation? We'll answer here, everything will be the same. The only difference is that standard deviation is equals the square root of variance. And standard deviation will therefore be equals square root of 14 over 3. That is it. You've solved. So, mean deviation, variance, and standard deviation, they are pretty similar steps. So for each of the questions, you see that we are finding the mean deviation, we are finding the variance, and we are finding the standard deviation. So all these are for ungrouped data. What if the data is grouped or in the table? What do we do? Now let's look at question B. We are given scores and frequency. So the score is taken as S. Remember I told you that when you have table like this, the one at the top is your S, the one at the bottom is your F. If you have tables like this side is your S, this side is your F, irrespective of the title that you see. So for S, we have 1, we have 2, we have 4, we have 5, and we have 6. For F, we have 3, we have 3, we have 4, we have 5, and we have 5. So what are the things we need to calculate mean deviation, to calculate variance, or to calculate standard deviation? In each of the cases, we need S bar. And S bar is mean. And S bar is equals summation of Fs over summation of F. Summation of F, anytime you see summation, it means addition. That is what summation means anywhere. So summation of F means addition of the F or addition of the frequency. Here we can just say summation of F is equals 3 plus 3, 6. 6 plus 4, 10. 10 plus 5, 15. Plus another 5, 20. So summation of F is equals 20. Summation of Fs simply means Fs means F times S. That is what it means. Summation means after you multiply F by S, add everything. So let's have Fs here. Fs will simply be 3 times 1, 3. 3 times 2, 6. 4 times 4, 16. 5 times 5, 25. 6 times 5, 30. So if this is correct, we have all these. This means summation of Fs is equals 30 plus 25. Is that 55? Yes. 55 plus 16. That is 65 plus 6. 71. 71 plus 6. 77. 77 plus 3. 80. So summation of Fs is equals 80. Now food is ready. Mean S bar is therefore equals 80 over 20. And that is equals 4. So the mean of this data is 4. So we don't use, instead of n, we use summation of F, which we've already done because we now have frequency. This formula we won't use, we'll use this one because we have a frequency table, there are F. So this requires us to find S minus S bar like we already used to, and to find F, which means you find S minus S bar, then you multiply it by F. Easy, not new to us. So draw a new table like this. Then write S minus S bar like this. So this is S and 4 is S bar. Here, S minus S bar is 1 minus 4. Here, S is 2. S minus S bar is 2 minus 4. Here, 4. 4 minus 4 is S minus S bar. Here is S, 5. S bar, 4. Here is S, 6 minus S bar, 4. Remember, absolute value. We don't do minus here. So where does that leave us? 1 minus 4 is 3. 2 minus 4 is 2. 4 minus 4 is 0. 5 minus 4 is 1. 6 minus 4 is 2. So we've got the summation of S minus S bar. But for mean deviation, we need the summation of F. No, not summation yet. We need F times S minus S bar. So this is F. This is S minus S bar. We multiply. That is what here means. So how do we do that? 3 times 3, 9. So this is F. This is S minus S bar. And S minus S bar is same thing as D. So this is FD. F3. S minus S bar is 2. So 3 times 2 is 6, if I am not wrong. 4 times 0 is 0, if I am correct. 5 times 1 is 5. 5 times 2 is 10. So this is Fs minus S bar. And we need the summation. So the summation of F S minus S bar, meaning add everything here. 10 plus 5, that should give you 15. Plus 0, 15 remains. 15 plus 6, 21. Plus 9, 30. So this is equals 30. This is, no. Yes, that is 30. So, summation of F S minus S bar over summation of F is equals 30 over, this is F S minus S bar, and this is summation of F over 20. So this is quickly give you 1.5 if I am correct. So 1.5 is your mean deviation. So easy. Now how about we're asked to look for the standard deviation or the variance? Now we'll do variance. For variance, the only difference is that S minus S bar will be squared. We deal with S minus S bar squared. What do you do? Here, you put S minus S bar squared. Let me clean here. What I am doing now is that I am now finding variance. So after looking for S minus S bar, you look for S minus S bar squared, which means everything here square them. 3 squared is 9, 2 squared is 4, 0 squared is 0, 1 squared is 1, 2 squared is 4. So this is S minus S bar squared. It is this S minus S bar squared you will now use to multiply F. So that is 3 times 9. That is 18 plus 9. 9 plus 8 is 17. So 27, if I am correct. F D squared. 3 times 9, 27. 3 times 4, 12. 4 times 0 is 0. 5 times 1, 1. 5 times 4 is 20. So here is now F S minus S bar squared. So adding everything will be summation of F S minus S bar squared. And this will give you 20 plus 1 is 21. 21 plus 12, that is 33. 33 plus 27, that should be 60. 60. So the summation of F S minus S bar squared is 60. And variance is equals the summation of F S minus S bar squared, which is here 60, over summation of F, which is 20. This will give you 3. So variance is equals 3. And therefore, if you ask for the standard deviation, after getting variance, you simply say that standard deviation is equals the square root of variance. That is the square root of 3. Food is ready. Now, let's see in this case. For class boundaries, this is what you do. Anytime you are asked for mean deviation, variance, or standard deviation, and you are given this class interval, you look for S from here because we don't use this interval to solve. How do you get your S? Your S becomes, this is S, 21 plus 25 over 2 is equals 21 plus 25, your answer divided by 2, that is the value of S. 26 plus 30 divided by 2 is your value of next S. 31 plus 35 divided by 2 is the value of your next S. 36 plus 40 over 2, the average, is equals 41 plus 45 divided by 2 is equals. So every answer you get here, they are your value of S. And here, each of the value, they are your F. You have S, you have F. So your assignment is to find mean deviation, standard deviation, and variance using the method we've been using. Nothing special. So do that and let me know your answer in the comment box. See you. Have a wonderful day. In the next episode, we shall start. What are we starting? Theory of demand. You don't need to miss that. And get your Flashlearners Jamb app and begin to play with questions.